when you did a worksheet a couple days ago, you did 2 word problems, and one of them was about a car loan and one or school loan, and one of them was about a car loan, right? Paying back a school loan and looking at how much your car was worth after a certain amount of time. Do you remember that worksheet? Our A value in that particular worksheet was $20,000. Does that help a little bit? Okay. We talked about that time a formula that looks similar to this. We said whatever rate we have, sometimes we have to add that to 1 if it's gaining value, and sometimes we subtract that rate value from 1 if it's losing value. You guys remember that? Okay, so the thing about this formula is that exponential equations don't always show up this way, but this is the way we need them to end up. So we've got to figure out how to get an equation like this into this form. Why would we want it in this form? Easier to tell what the rate is, right? That's exactly right. It's easier to tell what the rate is. If you look right here, you can't tell what the rate is at all because you've got just one number in there and you've got something in the exponent. The thing in the exponent is what's really kind of bugging us, okay? So let me show you on this first one how we're going to convert this back into this form, and then we'll talk about what everything means, okay? Remember when we did our exponent foldable? I know I keep pulling this out, but I told you it would be important to us, right? This power of powers rule right here, this is the one we're going to need to really think about today, okay? If I have, because what we did is we said if we have a power being raised to a power, we multiply those two things, right? Are we allowed to go from here backwards? If I have two things being multiplied, like these two exponents are, am I allowed to separate them? Like right here. Yes, that's where we need to be able to go today. So what I'm going to do is I'm going to rewrite this to look like this. 0.5 raised to the 1/28th raised to the t power. Does that make sense? No? That's a fair answer. Okay, 1/28. Well, right now it says t over 28, right? Is that the same as t times 1/28? Yes. So do you see how we can pull this value inside the parentheses with the 0.5? Because according to our rules, the power of power rules, if I'm multiplying two things here, I'm multiplying, or if I'm raising something to a power here, I'm multiplying, which also implies that if I'm multiplying them here, I could pull one of them into this and it'd be a power to a power. Does that help a little? Yes? Are you lying? Okay, good. All right. So, the reason that we pulled the one, wait, do you know why we pulled in the 1/28 instead of pulling in the t? Okay, that's a very good thing to notice. In the equation we're trying to get to, the t is on the outside. What's another reason why we didn't bring the t inside? Why we brought the 1/28 on the inside? Yeah, that's right. You can't raise the 0.5 to the t power, but can you raise 0.5 to the 1/28th power? Yeah, do you know it off the top of your head? Me neither, but I have a calculator. As do you. Okay? So I can say not yet. 0.5 raised to the 1/28th power. So I can get y equals a times 0.9755 to the t power. Is it okay that I rounded that one? Is that all right? Okay. Now, are we almost there, or are we there? Almost, because it's got to say either 1 plus something or 1 minus something, right? Well, we have it down to this. Do you think this might be 1 plus something or 1 minus something? Is this number greater than 1 or less than 1? Less than 1, so is it going to be 1 plus something or 1 minus something? 1 minus. That's exactly right. I'm going to have to subtract something to get to that. Okay? What do I subtract from 1 to get 0.9755? How'd you do that? Oh, you actually subtracted this from 1 to figure out what you would subtract to get to that? That's a pretty good idea. 0.0245? Can you tell her again? Does that make sense? So she subtracted this number from 1 to figure out what you'd have to subtract from 1 to get to that. Kind of a little backwards thinking, but you guys know how we are with that. We're okay with that. And guess what this is? Is it? Does it say y equals a times 1 plus or minus something raised to the t power? Done. Okay. Now, I want to do all the arithmetic on these, all the conversions, and then I would like to come back and talk about what it means. Are you okay with that? Okay, so look at the second example. What do you want to do first? Separate. Y equals a 3 to the 4th power t to the t power, right? Okay. Do we know 3 to the 4th power? I do. It's 81. Because I know 3 squared is 9 and that squared is 81. You okay with that? Only one more step. Do you know what it is? Oh, it is plus. Okay, I agree with that. 1 plus. 1 plus what equals 81? 80. Done. Pretty hard? Okay, awesome. Let's go to the next one. Oh, wait, did I give you a chance to write that one down? Sorry. Okay. What do we do first? Separate it. Okay, y equals a times 2 to the 1 over 5th. That's correct. Raised to the t. Okay. What is 2 to the 1/5 power? Do you know that one off the top of your head? 1.1487. Okay. What do you think? Adding. Okay, so y equals a times 1 plus what? Excellent. Last one, and then we'll go talk about why and what for. I'm also going to do this one 2 different ways, just for the record. Okay? 1/4 raised to what power? Oops. Squared to the t power. Okay. So what is 1/4 squared? Okay. Is it plus or minus? How do you know it's minus? The base is less than 1, right? So 1 minus what? 15 or 16. Now, a lot of people don't like it that way. Why? Because it's fractions, and some people freak out when there's fractions, right? Same way we've done it before. It's just different because it's a fraction. Some people would rather say from here, they'd rather say 0.0625. Well, I guess it's actually this step right here, okay, to the t power. So then y would equal a times 1 minus 0.9375 to the t power. People don't want to deal with fractions. Which one of these is more correct? Neither. They're both the same, aren't they? One's just in a fraction, one's in a decimal. Now, we're fortunate enough that sometimes our calculator will actually tell us the answer in a fraction. If we put it in as a fraction, sometimes it'll tell us as a fraction, right? But I wanted to make sure you understand that each one of those, both of these are correct. Okay? Now let's go back and talk about what they mean. Let's talk about this problem right here, that first example that we did. Okay? Think about a word problem that we've done like this, either the car loan or the car losing its value, or the school loan that we're having to pay back, right? Is this one gaining value or losing value? And why do you think it's losing value? It's a subtraction, right? What's the rate at which it's losing value? No, we talk about rates being as a percent, right? Is this a percent or is this a decimal? That's a decimal. So what's the percent that it's losing value? 2.45%, right? Does that make sense? Now, do we have to care what A is here? No, we don't have to care at all what A is here. It's telling us right now it's A. We don't need to care about that right now. We're trying to convert the decimal part, or excuse me, the equation part where it talks about the rate. That's what's important in today's lesson. Okay? Because in the next couple days we'll need to be able to do this knowing A value, knowing T value, and we're trying to find how much we owe or something like that. Okay? So today's one of those days where we figure out the arithmetic so that we can use it later on. Is this one gaining value or losing value? Gaining at what percent? 8,000%. I would really like to have a bank account like that. Okay? Just in case you were curious. Gaining value or losing value? Gaining value at what rate? So almost 15%, right? Okay. What about this one, gaining or losing? Losing at what rate? Yeah, see, this is a place where this one would be a better value, wouldn't it? Because this tells me the percent. This gives me a fraction. I'd have to convert it into a decimal, multiply it by 100 to figure out the percent, right? So are there times, you know that these are both equal, but are there times when one of them is a better, equation to use? Yes. Okay. So do you understand all the things about why about this so far? Knowing that I've got to teach you the arithmetic today, and later on in a couple of days we'll be able to use this arithmetic. You okay with that? Okay. So you have homework. It's written on the sideboard. It's on your lesson plans. Go ahead and get started on it.